Hello out there, welcome to this tutorial on logarithms. In this video, we'll be looking at logarithm of numbers less than 1, and we shall only consider the positive numbers less than 1. This is an introductory video. Check the description section of this video on our YouTube channel to get all the videos on logarithm of numbers using table. So we start. The numbers 0.7, 0.054, 0.0087, 0.00054, and so on are examples of numbers less than 1. Recall that the logarithm of a number has the integer part as the power of 10 when the number is expressed in standard form, the fractional part, which is obtained from the mathematical tables. Let's take 0.054 for instance. To find its logarithm, we have to express it as standard form. That's going to give us 5.4 times 10 raised to power negative 2. The negative 2 is the integer part of the logarithm of 0.054. We are not going to be writing it as negative 2 because the negative is only affecting only the integer part. So we shall write it as bar notation so that the integer part of the logarithm of 0.054 is bar 2, which is pronounced as bar 2 because the negative is only affecting 2. It is not going to affect the fractional part. So that the logarithm of 0.054 is going to be bar 2, which is the integer part, and the decimal fractional part is 7324, which is obtained from the mathematical tables. It is the integer part of the logarithm of the number less than 1 that makes it different from the logarithm of numbers greater than 1. We have treated that one in our previous videos. Then check the description section of the video on our YouTube channel to get them. Now we look at basic operations on bar notations. So we start with addition. Evaluate each of the following. We have problem 1 to 4. So we start the solution from 1. Problem 1, we have 2.47 plus bar 3.26. We're going to use a tabular form. So we have 2.47 plus the integer part here will be placed under the 2. You still remember your addition of decimal numbers. So the bar 3 is under the 2, we place our point. The 2 is under the 4 and 6 is under the 7. Then we add 7 plus 6 gives 13. You write 3, carry 1. 4 plus 2 gives 6 plus the 1 you carry gives 7. We place our point. Here we have 2 plus bar 3. Remember this bar 3 is negative 3. So we are going to treat it as such. So we now have 2 plus negative 3. And 2 plus negative 3 gives 2 minus 3. 2 minus 3 gives negative 1. And this negative 1 again, transferring it to this place, we have it as bar 1. So that's the end of solution to problem 1 for addition. Now problem 2. We have 0.15 plus bar 1.53, still in a tabular form, 0.15. Then plus the bar 1 is coming under the 0. Place your point. 5 is coming under 1. And 3 is coming under 5. We then add 5 plus 3 gives 8. 1 plus 5 gives 6. You place our point. Then we have 0 plus bar 1. That's going to give us 0 plus negative 1. And 0 plus negative 1 is 0 minus 1. and that gives negative 1. Again, we write it as bar 1. So we are done with problem 2. We then go to problem 3. For problem 3, we have bar 3.61 plus bar 2.33. Again, in a tabular form, bar 3.61, then plus bar 2 is coming under bar 3. Place your point, then 3, 3. We add from behind. 1 plus 3 gives 4, and 6 plus 3 gives 9. Place our point. Bar 3 plus bar 2 will give us negative 3 plus negative 2. Removing this bracket, I have negative 3 minus 2. Minus 3 minus 2 gives negative 5, which is written as bar 5. Then we go to problem 4. Bar 2.91 plus bar 5.68. In a tabular form again, we have bar 2.91. The bar 5 is coming under bar 2. So we have it as bar 5.68. So we add 8 plus 1 gives 9. 6 plus 9 gives 15. We write 5 and carry 1 to this place. We have our point. We have bar 2 plus bar 5 giving us negative 2 plus negative 5, giving negative 2 minus 5. That gives minus 7, plus the 1 we are carrying over to the integer part, and that will give us plus 1, giving us negative 6, and it is written as bar 6. And that's all for problem 4, and that is what we are taking on addition of bar notations. We then go to subtraction. For subtraction, we have to evaluate each of the following. So in our solution, we start with problem 1, 1.89 minus bar 3.32. So we arrange in a tabular form again, 1.89, then minus bar 3 is coming under 1. Place our point, the 3 is coming under 8, and the 2 is coming under 9. So we start subtracting from the last digit. 9 minus 2 gives 7. 8 minus 3 gives 5. We place our point. Here we have 1 minus bar 3. That's going to be expanded as 1 minus negative 3. Negative times negative gives positive. We have it as 1 plus 3, which gives 4. So the integer part here is 4. Then we go to problem 2. 0.67 minus bar 2.53. We arrange again. So we have them arranged here. Then 7 minus 3 gives 4. 6 minus 5 gives 1. We place our point. So we have 0 minus bar 2. This is expanded as 0 minus negative 2, which gives 0 plus 2, and that gives 2. So we have this integer part here to be 2. So that's all for problem 2. We then go to problem 3. So again, arranging them, we have bar 2.83 minus bar 1.42. So we carry out the subtraction again from the last digit. 3 minus 2 gives 1. 8 minus 4 gives 4. Place our point. So we have bar 2 minus bar 1. That's going to give us negative 2 minus negative 1. Removing this bracket, I have negative 2 plus 1. That gives negative 1. So bringing it here, it becomes bar 1. That's all for problem 3. We go to problem 4. I have bar 3.12 minus bar 2.95. So bar 3.12 minus bar 2.95. So we are borrowing here. Remember 0 there. The one we borrow is here, making 12. 12 minus 5 gives 7. We are left with 0 here. We borrow 1 from here. We'll be left with bar 4. Remember, it is bar 3, which is minus 3 minus 1 from it. We have minus 4, which is this bar 4. Placing it here, we have 10. 10 minus 9 gives 1. We place our point. So when we borrowed 1 from negative 3, which is bar 3 here, we're left with negative 4. That is bar 4. So we now say bar 4 minus bar 2. That's going to give us negative 4 minus negative 2. Removing the bracket, negative 4 plus 2. Negative times negative gives positive. Negative 4 plus 2 gives negative 2, which is brought here as bar 2. So we go to the last problem under subtraction of bar notations. So we arrange again 0.29 minus bar 3.84. So 9 minus 4 gives 5. We can save 2 minus 8. We borrow 1 from 0. We'll be left with bar 1. Remember, 0 minus 1. We are taking away 1 from 0 to bring to this side. And so 0 minus 1 gives minus 1, which is written as bar 1. So we place the 1 here. That is 12 minus 8 gives 4. So we are now left with bar 1 minus bar 3, which is going to give us minus 1 minus negative 3. This is going to give us minus 1 plus 3. Minus 1 plus 3 is 2. So this is brought here under the integer part as 2.45. And that's all for subtraction of bar notations. We go to multiplication. So for multiplication, we have these problems to be evaluated, 1 to 4. So we start the solution from 1, bar 2.14 times 3. This is going to be done in the tabular form also. So we have bar 2.14 multiplied by 3. So 3 times 4 gives 12. You write 2 carry 1. 3 times 1 gives 3 plus 1. You are carrying 4. We place our point. 3 times bar 2. That's minus 2 times 3 gives minus 6. That's going to give us bar 6. That's all for problem 1. We then go to problem 2. Bar 1.32 times 2. So arranged again, we start the multiplication from the last digit. 2 times 2 gives 4. 2 times 3 gives 6. And 2 times bar 2 gives bar 4. So you still remember minus 2 times 2 gives minus 4. Minus 4 is written here as bar 4. Then we go to problem 3, bar 4.75 times 5. Arranging in a tabular form again. 3 times 5 gives 15. You write 5 carry 1. 3 times 7 gives 21 plus 1, 22. You write 2. And carry our 2 to the integer part here. So place our point. 3 times bar 4 gives bar 12. And bar 12 plus 2 gives bar 10. That's minus 12 plus 2 gives minus 10, which is written here as bar 10. And that's all for problem 3. We go to problem 4. In a tabular form again, we have it as bar 2.87 times 4. 4 times 7 gives 28. We write 8 carry 2. 4 times 8 gives 32. 32 plus 2 gives 34. We write 4 and carry 3 to this integer part. Place our point. 4 times bar 2 gives bar 8. Bar 8 plus 3 gives bar 5. That's all for problems on multiplication of bar notations. Then we go to division. So for division, we have to evaluate each of the following. And without much wasting of our time, we go straight to the solution, starting from number 1. So we can write this one as 2.84 over 2, because this is 2.84 divided by 2. We need to recall that for every decimal number like this, we can split them into the whole number part and the fractional part. Like the whole number part here is the 5, which is the integer part as it is being referred to here. Then the fractional part is going to be plus 0.76. In the same way, we are going to split this. So that's going to give us bar 2 plus 0.84. Then we can then divide each of the components by 2. So this bar 2 is going to be divided by 2. 0.84 will be divided by 2. You can see now that bar 2 divided by bar 2 will give us bar 1. Then plus 0.84 divided by 2 gives 0.42. Adding them together, that is reversing this process now, we have it as bar 1.42. That is all for problem 1. Then we go to problem 2. And if you look at this bar 1, it cannot be divided by 2. Remember, we said the minus is only affecting the 2. So we cannot say it goes 0 times and carry the minus to this side. So in this case now, we are going to do some manipulations. Look for the smallest number divisible by 2, which is 2 itself. And we make it a bar notation. So we have it as bar 2. Remember, we have bar 1 here, and here we are taking it as bar 2. So the manipulation is add a number to this bar 2 to make it bar 1, and that is 1. Because bar 2 plus 1 is expanded as minus 2 plus 1, which is minus 1. So we add the what? The 1. This means this bar 2 plus 1 is giving us bar 1. Then we now place our point 0.75. So this is expanded. It is still the same value with this. It is expanded, but the same value with this. Then we divide each component again by 2. So this is divided by 2. This is divided by 2. So bar 2 divided by 2 gives bar 1 plus 0.875. If 1.75 is divided by 2, we have 0.875. Remember, we are dealing with 2 decimal places. So we are going to resolve our answer as 2 decimal places also. And we have it as bar 1.88. This is rounded up to 1 to be added to this 7 to give us 8. That's all for problem 2. We then go to problem 3. For problem 3, we have bar 2.98 divided by 3. So again, we are writing it as bar notation, which is divisible by 3, and which is going to be exactly 3. So we have bar 3. We are adding 1 to this bar 3 to give us bar 2. That is the method of expanding this. So we have plus 1, then 0.98. 0.98, divide each component by 3. This is divided by 3. This is divided by 3. So bar 3 divided by 3 gives bar 1 plus 1.98 divided by 3 gives 0.66. Then adding them together, we have it as bar 1.66, which is the result obtained from dividing bar 2.98 by 3. Then we go to the last problem, which is bar 3.87 divided by 5. Again, this 5 is not exactly divisible by this bar 3, so we can have bar 5 exactly divisible by 5. We then add 2 to bar 5 to give us bar 3, so we have it as plus 2. Then we place the rest numbers 0.87, then divide by 5 here, divide by 5 here. So bar 5 divided by 5 gives bar 1, then plus 2.87 divided by 5 gives 0.574. And we are interested in two decimal places, so we have it as bar 1.57. Since this is not up to 5, it is rounded down. And that's all for the division of bar notations. And this is the highest we can take in this tutorial. Remember, we told you this is an introductory video of logarithm of numbers less than 1. So check our next video on multiplication and division, powers and roots. Until we come your way again, goodbye.